So in this problem, I'm going to use a Venn diagram structure to just visualize what they've given us and what they're asking. So this outside box represents the entire class of 236 students. They tell us that 142 took algebra, that circle, and there's an overlap. 121 took chemistry, and there may be some students that took neither. I'm just going to call it Y. And then let's say X is the overlap. The question is, what's the greatest possible number of students that could have taken both algebra and chemistry, meaning how to maximize this overlap? So one way to visualize this is that I can slide this circle inside the algebra, and because this is the smaller quantity, I can think of it like this, that all the people who took chemistry also took algebra. So this circle is 121. In fact, that would be X. And the algebra is 142, and only algebra would be this region, which is 21, and the total is 236. So the maximum I can make, the overlap, is 121 is the answer. Now, in that scenario, the number of students that took neither would be 236 minus 142, which is 94. So the answer to this question is just 121. Another variation that could be tested is, what's the least number? So I'm looking at the other extreme. What's the least number of students that must have taken both algebra and chemistry? And so in that case, I'm going to just add these different categories, 142 minus X, and then this is 121 minus X. And if I add all these regions, that has to be equal to 236, and includes neither. And then X's drop out. These two, that's 263 minus X plus Y. I subtract this, I get 0 here. This is 27. So I get X is equal to 27 plus Y. Now the Y, the least it could be is Y is 0, which means that X has to be greater than or equal to 27. So watch out for that variation too, where they might ask you what's the least number of students that took both algebra and chemistry. But just to recap, the answer to this particular question is 121.